Hello, everyone. Welcome to today's webinar. It's on cable harvest planning with RoadEng Forest Engineer. For those of you here in the live version of the webinar, like always, we ask that you engage with us as we're going through it. You can use the Q&A section of your GoToWebinar panel to type in a question, and we will address those at the end of the webinar. For those of you watching this in the future off of our YouTube channel, feel free to ask us questions or put comments below, and we can respond back to those. So cable harvest planning and analysis can improve, both your equipment and your landing locations. And with that, allow you to increase the efficiency a little bit of your harvesting operations. We've had lots of new changes to our cable harvesting functionality in our most recent version of RoadEng and Terrain Tools. That's version 9. These improvements include changes to the UI, the super fun thing that Dave's going to show you today, which is called Explore Mode. So it's a color-coded deflection explore mode that displays a loggable polygon. We've got auto tail calculation, lots of improvements in terms of loading in defaults with your logging systems and equipment, improved profile display, and more. So a brief introduction here before we pass it over to Dave and you can get into the software. I did want to take us through a little bit of a workflow for cable harvest planning using RoadEng. So we start with our ground profile. This could be LiDAR, P-line, etc. And in this webinar, we're going to start with an existing LiDAR surface that actually has our roads already in it. From there, we're going to set up, oops, here we go, configure and set up our logging equipment and our logging setup. So here we're talking about our cable configuration, working tensions, cable weight, carriage weight, etc. And this portion kind of operates much like a template in RoadEng in the sense that you set it up once and then you can actually reuse that logging setup and that equipment setup again in the future, which is what we will be doing in the webinar here today. From here, we're going to be using Explore mode to find areas with good deflection based on that equipment and that logging setup. We can select and modify our D-lines of interest to accommodate our local topography. And then the fun part is then we get to conduct the payload analysis. And we can create an output sheet, which we call Multiplot in RoadEng. This now can actually be, as a version 9, this can be geo-referenced. So this way we can take that Multiplot sheet out in the field in other programs like Avenza Maps. And you can connect it with the GPS in your device so that you can see where you are in that output sheet. So from here, can I pass it over to Dave? I did just want to make one kind of little disclaimer. Our title of the webinar mentions RoadEng Forest Engineer, but the cable logging functionality that we're going to be showing you today, it's actually also available in Terrain Tools Forestry. The reason, we're keeping the RoadEng Forest Engineer in the title. We do have some roads shown in our terrain module. They're required to be done in the road design location module that comes with RoadEng. So the core cable functionality available in both. And with that, let's check out this workflow in a live example. And I'm going to pass it over to you, Dave.
Thank you, Erin. And there is the terrain as mentioned. This is a LiDAR version of a piece of northern Vancouver Island. I'm showing some contours and some existing roads. The roads could come from something as simple as a GIS line. I actually traced these on an image, and of course you can display images in terrain. Let's just turn this one on, and you can see there that this area has already been logged, and there are indeed roads up in here, even though you can't see them in the LiDAR. Down here, you can see the bump that indicates the road, but this road here was post LiDAR. Okay, so we got a surface. Let's just turn off that image because I think it's clearer if you're not looking at the image. And where do we want to log next? Well, this area over here hasn't been logged. There is a road coming in from behind. There's this nice little hill here. You can see my cursor moving in the 3D window while I move it in the plan. That's because my active window, the 3D window, sorry, has the track mouse checkbox turned on. Very useful feature. Okay, so that little hill lies near this road here. Do we want to put a road up there? Do we want to take the material back to the road and make landings on the road? These are the kinds of decisions we make when doing logging planning. I'm going to show you the tools that make that a lot easier. So first of all, you can't do much with the cable analysis software unless you set up equipment that is meaningful to you. So this has already been done. In a day-to-day workflow, you don't have to do any setup. I've got a grapple yarder in here. I think we're using this one actually. And it's been set up with a 100-foot spar and various cable tensions. And that has also been incorporated into a system. The grapple system that I'm going to use uses that particular yarder, and it's a running skyline with grapple, which weighs about 4,000 pounds. Okay, so I did that setup earlier. Notice the save as default here. And this is my default. I'm ready to go. So the day-to-day workflow does not include setup. You certainly have to set up your surface, but we're not going to cover that here. So now, where should I put my landing? Let's go to the cable analysis and the plan window and click on this new feature in version 9. You may have seen it in some of our webinars already. We call this D-Line Explore. What it allows you to do is to create a whole bunch of deflection lines all at once. I'm going to do 12, so it's going to radiate from my landing location and produce 12 deflection lines. Set up a maximum length here of 300 meters. I'm going to leave the defaults for auto tail hole position. We'll discuss that a bit later. And show area polygon. Okay. And finally, let's just put a little tail hold height. We'll say there's a 5 meter spar. Maybe it's on a tree. Something like that. One more thing, we need to set up the calculation. So there are a lot of technical details to your calculation unless you use simple third point deflection. This is just a graphic. You choose the deflection, it'll draw the classic third two deflection points and the two end points. So divide the D-line up into 3 pieces. I'm going to use that for now. It works fine for calculating deflection. We'll do a payload analysis later. So I'm ready to go. Click on OK. My cursor changes to the big star here, which shows actually 8 lines radiating out. And if I click anywhere, how about here? Okay, I don't need to say that warning again. I'm just a little bit near the edge of my surface, as you can see over here. And it draws deflection lines, and it finds the end point of each of the D-lines according to clearance. It finds cables with clearance. If I put my landing on top of this hill, of course I can go in all directions. These ones are a little bit shorter. Why is that? Let's just look in the 3D and see if we can figure it out. Oops. I want to get my zoom just right. So this point here is, oh yeah, we're just going along the hilltop, so we're not getting much deflection. We can look at that profile in a second, but let's pick a spot that kind of makes sense. Okay, the other thing would be to maybe put it over here on the road, and then clearly that hill becomes my boundary. We're not going to be able to log over the hill, or at least yard over the hill. I'm going to pick this spot here. So that goes back, and now I'm going to accept it. So I've chosen a landing location, click on the accept button, and it anchors down those deflection lines. I don't know if you noticed, but it was displaying the area of this boundary here, 18 hectares. And of course, that would be reasonable if we were to put a landing there and log in all directions. But now I want to show you how you can be a little more custom about where you're. Oh, and by the way, it's put this whole thing in the 3D window. You can see the third point deflections there. And now I'm going to make room for looking at just one of these and maybe make a few custom changes. First thing I'm going to do is I think I'll just get rid of this boundary polygon for now, because that's not going to be very true in the future. I'm going to delete that. Okay, let's look at one of these ones that got shortened. So I chose this landing location here, and you can see that there's my 300 foot or meter point way out at the end. Why did it stop here? Well, let's just look at it. So I'm going to select that D line. It's called DL Explorer. They all are. This is number 4. And I'm going to put that in a profile window. There it is. And you can see what's going on. So new feature in version 9, profile options, you can say auto, always look at the current feature. What that means is that every time you select a new feature, the profile window updates to show that feature. And let me just turn off auto scale so we can put it where we want. So again, this D line here stopped right there. That was the best place to put the tail hold. So when I set up the Explore options, I chose auto tail hold position, and I set the minimum clearance to 0. So it's just doing the simple third point deflection. That's what I asked it to do. And it's moving the tail hold back and forth and finding a spot where it gets clearance everywhere. If I were to move the tail hold back, then obviously I would start bumping into this hill. Let's just do that. So this is the current feature. If I click on the edit button here in the cable analysis ribbon, I can set up all the details for that. So if I change the station to a different spot for the haul back block or the tail hold, then it'll come out different. So let's just do that. 200, okay, and boom, yeah, you can see we're hitting this hill and going underground there. So that's not a good spot. One of the things that you probably, if you've used the software in the past before version 9, one of the things you probably did was to set the haul back position to be a big number and then just move it around by hand. You can still do that. So here we have a profile, and I can pick up the end, move it around, anchor it down, and it instantly updates and shows my graphic there. So if I moved it back to here, oops, that's a bad spot on this hill. That's good, but of course we can't get behind it. What happens if I move over here? So the idea is you can customize. Now I've chosen a new spot for this particular yarding road, and you can see that it's going underground a little bit here, and you can see that in the plan view with a red marker. Back to the edit window. This little button here says, find me the tail location that will produce the largest amount of clearance possible. So I'll click on that. It comes up with a number, say okay, and boom, there it is. So it says move the tail hold back to here, and then you get clearance all the way back to the landing. Sometimes when you've got a hill, where's a good example of that? Here. You get an interesting effect. So no, not in this case. Maybe we'll find one later up. The point is you can move these things around, and you can duplicate them and make new ones, and you can customize them. So back to the workflow thing, when we do this is only available when the plan window is selected, by the way. When we do the Explore, it comes up with a bunch of suggestions. You can change them by modifying the alignments or adding new ones. So for example, I can just select this one and say, well, let's duplicate it. I can use the duplicate button. I could also do copy paste, Control C, Control V, and I have a brand new one there. It's got the same settings and so on, and I can play around with it. So I've added an extra yarding road by duplicating one and moving it around. I've got a bunch of them here. We've had a customer point out that modern yarders don't use a fixed spar. The spar actually rotates with the machine, and the effective position of the spar is actually a little ways along here. So I'm just gonna do that now. Unfortunately, the D-Line Explorer always Okay, we lost audio for a second here. Hopefully we can figure that out later with video editing. I was just saying that often it makes more sense to have the tower position a little bit ahead of the landing, because the yarder sits there on its giant tracks and the tower actually leans out at an angle. So it's not actually at that point, it's a little ways along. I'm just going to do that by selecting all of these cable roads, D-Line features. They're all called DL Explore. Go into the edit options. I've got multiple selected, yep. And I'm just going to change the start station a little bit. Let's say 10 meters. I don't know if that's right. That's reasonable. We'll see it anyway. And OK. And if I click on Auto Count Tail Station, it'll redo them all when I click on OK. There we go. So I've now moved my tower position away from the landing a little bit to represent the shape the rotating yarder would have. And at the same time, I updated all the tail holds to give me the maximum distance. Right, do that multiple times. We're not going to have just one landing, we'll have them all over the place. And of course, if you didn't want to, like this area has been logged already, if you didn't want those ones, well, just select them, click, shift click, shift click, shift click, and hit the delete key and they're gone. Yeah, and you know, this is way up at the top of the hill. Do we really want someone to climb up there? Probably not necessary, so I'm just going to move that one down until I get deflection and I cover the area that I'm interested in. Now, that may be all you need to do. I want to cover payload analysis, but let's keep on in the same vein of setting up landings and tail holds. Now I want to know where all this stuff is. So first of all, if you've got a georeference map, and you probably should, then you know these points are well defined. Every point has a well-defined coordinate. You can see the coordinates down here as I move my mouse around. And if we print this out, it'll go to a georeferenced document. Well, first of all, we can display coordinates. Let's just look at this one here. I'm going to go into Feature Tools, Labels, and I've got one in here called Northern Easting. Let's turn it on and let's bump up the font size a little bit. Okay, Okay, there we go. So there's coordinates. If I don't want the ones at the tower, I can just select that. Whoops, I'm in the wrong mode here. Labels, I can just select that one and delete it. Label edit mode. And we could do that with all the points of interest along here. The other thing that you can do, and of course we can make a drawing. So this is the plan window. If we just print it out, it'll look like that. Here we go. There's your piece of paper or PDF document. But we could also put it into our multiplot window and dress it up a little bit. So as Aaron said, often output is done in the multiplot window, and this allows you to add all kinds of things to the window, including the plan window and title blocks and north arrows and graphics and so on, to make pretty output so you can send it off again to your printer or your PDF writer. What if I wanted to just look at all the D-lines in an output? Well, we can do that with Multiplot as well. And I'm just going to open a screen layout to do that. So this screen layout, I pretty much made it organically just by moving windows around and adding new windows. But you can save those things. So if we go to the View menu, these are screen layouts that have been saved on my hard drive. I can click the Save button here to add a new one. And I've created one called Cables MP Multiplot. Let's open that. This is, again, using the multiplot window. We've got 4 deflections, but they're not showing anything just now. So there's a little bit of work to be done to make these things work nicely. We've set up the multiplot so that all these windows, let's just look at the options, have use current feature and auto position. That is not very useful for actual output, but it's a good way to get started. Now I'm going to set it up so that they display the features I want. So which feature do I want in D-line 1? Okay, so here's D-line 1. That's the one we can see there. And I can choose any one of these. Let's choose this one. So I pick in the plan window. There it is. There it is. Now I'm going to lock it down. So now the first one is locked to DL Explorer 5. Good. And I'm also going to scroll it to the same position as all the others. So let's make it 50. Well, there's only one now. And I think I want to be a little higher than that. How about 320? See what that looks like. Okay. Now let's do the number 2. Okay, number 2 is not this window, but this window. So in the multiplot, we've got a real profile window here. Looks like that. You can see it's echoing in the multiplot subview. And I'm going to change the feature by selecting the current feature, and that updates. I could just do it by like this by hand. That's good. And then go in here, double click, options, lock it to DL Explorer for number 4. Okay. And lock down the position 2. Let's make it the same as the one above. Is 320 going to work here? I'm not sure. Let's just try it. Not bad. Okay. I'll do one more. That's all the, just to illustrate how it works. Okay. So here's profile number 3. Whoops, wrong feature. Let's select that one. And it looks okay. Go in here, lock it down, and set up the scroll position. Now I can print this and I've got a record of what I want. We've got a little bit of extra information underneath here. That is configurable. I'm not going to go into the details about Multiplot now, but this screen layout, I think it comes with your install. I'm not sure. If it doesn't, we'd be happy to send it to you by email. It's just a tiny little file, or you can build one yourself. These are just little windows you can move around. You can create them here with a right click, and they all have options. There's the sub-window options. Okay, so output, plan, profile. Now let's do a little payload analysis, and then I'm pretty much done. So back to, how about the same screen layout we were looking at before? I think that was just my normal. Do I have one set up here? Max loads. Oh, here's a screen layout for doing a payload analysis. I'm going to use that. Okay. How did I set this up? Well, let's actually go back to the this one. That's the one I started with. Got a 3D window, it's just recalculating. We've got the plan window, and we've got one profile, and we can look at any of the D-lines that I've anchored down and the ones that I've modified by hand. To do payload analysis, you probably want to set up a few options. So first of all, in the profile window, I can choose to display things underneath. Now this is only available when you have cable analysis as a function group. So it's in the, actually all the stuff I've been showing, the cables, ribbon, and so on, is available, as Aaron said, in the forestry versions of our software. Okay, and there's a bunch of things we can put underneath the profile that represent, well, percent deflection, tensions legend, various, how about load? Let's shift that up, like so. Okay, go. And they're all pretty much blank right now. And the reason for that is that I'm doing a simple third point deflection, which doesn't actually calculate anything. So let's go back to the cable analysis ribbon and edit this particular yarder. We can actually we can do them all if you want, but let's just do the one. So I'm going to edit this particular feature, DL Explorer number 0, and I'm going to change the calculation parameters. Instead of simple third point deflection, I'm going to do deflection for fixed skyline given load. So here you type in the load and it will show you what the carriage path looks like. It's doing 10 samples. You can do more if you want. Let's see what that looks like. So the graph that I put underneath here, load, is flat. It's exactly 20,000. That's what I set. The deflection, it actually does move a little bit, but you can't tell by looking there. And you can see the tension on the lines, and you can see what the cable looks like. And now we've got a little bit of red at the end because we can't actually lift that much load clear of the ground. So this maybe I should have set this up as my calculation in here when I was doing my Explorer. I can do that. That's totally allowed. Okay, let's do a different kind of calculation. So again, for this particular feature, I'm going to change the calculation to do minimum deflection. No. Oh, I had the wrong one set. I meant to do minimum deflection given load. Okay. There we go. Now you can see that the deflection does actually change. Also, it's going way down there. Oh, that's interesting. Minimum deflection. What did I do before? Deflection for fixed skyline given load. Oh, that's interesting. It was over the fixed skyline uses a percent deflection. And it ignores the cable tension. So we actually overloaded the cables. Let's look at that again. These tensions are larger than the tensions that I'm allowed. There's 50,000. And in fact, if I turned on the error bars, there it is, errors. Okay, so back to calculation parameters. This is the one that I meant to choose. So we need a smaller load. So let's say 10,000 pounds. In this case, we're not setting the deflection, we're calculating it based on the load. There we go. And so 10,000 pounds is going to hit the ground here. It's not going to cause any errors. It's not exceeding any tensions. That's what the calculation is all about. How high can we lift it without breaking the yarder? But clearly, we've got a clearance problem. Well, there's one more calculation that I think is worth looking at. What if I require clearance, and I'm just going to set the clearance to 1 meter? How much load can I lift? And there we go. So 1 meter above the ground, there's a couple of places where we didn't sample that it's actually hitting the ground. If I increase my sample spacing, decrease my sample spacing, increase the number of samples, say to 20, then it's bumping up over those things. So there's a bunch of places where it's sampling here, and you can see what the load is. If I lift this up a little bit, yeah, there we go. Now we can see that. So, and this is pretty typical of a real cable. You would expect that near the yarder, where you've got a steep angle up to the top of the tower, you can lift lots of stuff. As you get further out, your load limit goes down. And as you can see, it's getting down near around 10,000, which we saw from that earlier example. And these are the tensions in your, oh, now why am I getting such a big tension there? I don't know, I'd have to think about this. Maybe I've got a big mainline tension allowed in my yarder. I'm using this one, edit, and oh yeah, oh no, the skyline's not being used. This is mainline haulback only. I'm not sure what this means. That's a payload analysis. We can look at what kind of load we can lift, and if you've got a situation where there's a real bump in the middle, then you tend to have a minimum where it has to clear the bump. So let's just look at such a situation. How about we go to this one and move it so that it goes over that bump. There we are. Now I didn't change the calculation parameters on this one, so I need to do that. They're all independent. If you select multiple D-lines, you can change them all at the same time. And the D-line information, the tower, the tail, the calculation, it's all stored with the feature. So if you copy and paste a feature, you're making a new draped feature, but you're also taking all this stuff with it. Is that the way I wanted it? I think I changed that to 20, but this looks about right. Okay, and okay, and there we are. And oh, one more thing. Let's just make that a big number. I'm doing this manually instead of using the auto tail calc. That puts it there. But let's just force it to be at the end. There we go. And now you can see typically what happens when you have bump. Your load over the bump is reduced, and even though you can pick up more stuff here, you can't clear the bump, just as you would expect. That's payload analysis. Again, every window here can be printed by itself, or you can set up a multiplot that contains things like this window, this window. Oh, and there's one more. I meant to show you that. Let's go to my screen layout. There's also a table window. You can get it from the view, new window, cable data, or as I did, save it with a screen layout. And that window has options very similar to the subviews under here. You can choose what items to display in the table. And I did 20 sample points, so there's 20 lines there. And have we done this now? I think it's only in version 10 you can copy this to clipboard, unfortunately. In version 9 you still have to print that out, or yeah, I thought we would have put that back in version 9. Anyway, there's a bunch of tabular information which you can print, and you can see as you're playing around. There's my low point there, 1,000 pounds, and then it comes up a little bit at the end. That's this bump here. Great. Any questions?
Awesome. Thanks, Dave. Let's give our viewers a few seconds here to start typing in their questions. So just if you can't see your GoToWebinar panel, you just need to expand it out, and there is a little Q&A section there for you. Dave, so we've got our first question. How can I take, oops, sorry, I gotta expand my window here. How can we take the landing and tail locations to the field?
Right. Well, you can certainly print these things to PDF, and there's a great package called Avenza, which runs on phones and tablets, and it will allow you to create a geo-referenced image. And we don't actually print that to PDF. We use a zip format, but Avenza PDF Maps does read it, so you can save as Avenza Maps. And what it does is it allows you to, let me just put this in here. I'm just going to create a file called avenza.zip in my folder. And here are the options. What it allows you to do is to take a picture of the plan window and choose your pixel resolution. So screen resolution is the default, but you can make it higher resolution if you want, and it will become a more clear image. So for example, if I change this to 0.5, I'll get a bigger image and it'll be more clear. And it tells you how big it would be. Uncompress it. It goes into a zip file. It's actually a JPEG and a couple of other files that go in there that allow Avenza to figure out the coordinates of any of these points. And then you can take that into the field and basically walk out to your tailhold and see your GPS location blinking on your map, so you can find it.
Awesome. Okay, our next question. I don't have LiDAR. Can I still use this?
Of course you can. Oh, I canceled out of there. That's why it failed. You can create a profile any way you want. Now, I've been creating these profiles by simply draping a feature. I didn't show that too clearly here, but this feature is draped. So it's got no intrinsic elevation. It's picking the elevation up from the model, and that's how I get my profile. But if you've got a profile in another format, for example, you could actually survey in our survey map module and bring it into terrain, and then you can just use that profile. Do I have one handy? That's a good question. I don't think so, but you don't need to have a LiDAR map. All you need is a profile. Yeah, let me just demonstrate. I'll just take this feature here, and I'll copy it to the clipboard, and then I'm going to start a whole new terrain. I've got another, let's just start a new terrain. And paste that feature. No, it's not on the clipboard. Okay, back to my other one. And here, copy, paste. There we go. Okay, so there's my feature, and it would be a proper 3D feature. It doesn't need to be modeled. And now I can do things like look at that in profile and do all my cable analysis stuff. So here's a terrain that has one feature in it. You could have imported that feature from our survey map module. You could have read it in from a another file format like shape, for example. Shape doesn't usually have elevation, so that may not work so well, but XYZ ASCII would work. Anything that gives you 3D coordinates for your profile.
Excellent. So we're going to tackle, I think, just 2 more questions because we've gone over time per usual. And I think you might be able to handle these 2 together. So the first one is, could you demonstrate how to set up the logging system in a bit more detail? And the next one was, does the program come with preloaded yarders with manufacturer specs, or must all yarders be created by the user?
Well, let's answer the last one first. We do provide preloaded yarders, but don't trust them. They're just there as an example. So let's go to the cable analysis ribbon. Here's the setup. Simple. You need to create 2 sets. First of all, you create yarders. I think a few of them are in there when you open the software, but you should modify them or delete them and add your own. So what is a yarder? Let's just add one. I've got one here called David's yarder. Let's add another one. Okay, so it's called new equipment. This is really all you need to define a yarder. You need a name, you need a spar height, and you need cable tension and weight per length for all 3 drums. Now, of course, in a simple grapple yarder, there is no skyline drum, so these numbers are ignored, and you can put whatever you want in there. The other thing that's kind of embarrassing is the maximum length is also ignored. So those numbers are there for your reference, but they're not used anywhere in the software. And you can change your units if you want. Okay, so you've created a list of equipment, and then you can create logging setups. So each setup is, let's add a new one, new setup. Basically, you choose a yarder. There's my new yarder, and you choose a cable configuration. And these are hard-coded. You can't change them, but I think it covers all the possibilities. The most common ones are things like skyline with motorized carriage, running skyline, or grapple. That's only got 2 drums. You pick one of those, and you can choose one more parameter. You can put a weight on the end. So it's very quick to set up. The only things that you need to look up in your specifications are, and you can save as default for future use. The only things you need to set up in your, you need to really be careful about are the cable weight and working tension. Those numbers are important, and most people don't know them off the top of their head. You're going to have to look them up. Sometimes the yarder will just come with a specification like 3/4 swedged, and you need to look up how heavy is that and what's its working tension. Right, so don't, yeah, go ahead and use the ones we've got, and don't worry about any of this stuff if all you care about is simple third point deflection, because there is nothing except a tower height being used here for calculations. But if you want to do actual payload analysis with these three options, make sure you set up reasonable cable strengths and weights.
Awesome. Thank you, Dave. So I just wanted to, thank everyone for attending. I think we're going to call it there. We're 15 minutes over, which in terms of our webinars, I guess that's not that far off of what we usually do. So thank you, everyone, for attending. If you're watching this in the future on YouTube, feel free to ask a question through the comments below. And that's it. Have a great rest of your day, everyone.
Bye now.
Thanks for watching another SoftTree webinar. Please be sure to subscribe to our channel below or tell us that you liked the video. Thanks for watching.